Tabasso. So today I will explain about the uh, style based global appearance flow for virtual try-on paper. So first I will go through the overview and demo. Then I will discuss about what I have learned from this paper. So nowadays, online apparel shopping getting more and more popular in our daily life. There are so many online platforms from we can buy clothes, but online apparel shopping has problem when it comes to check target clothes if it fits in our body or not. So this increase the 30% return and loss rate in online shopping. To solve this problem, virtual try-on was introduced. So virtual try-on models take the two input as a person and garment image. Then it will give a output of the image with the person wearing the target cloth or garment. So it use a warping module, as you can see here, to provide the output. So it also use image to image technique for the output. But virtual try-on has a main challenge of misalignment between person and garment image. So to solve this problem, style-based appearance flow virtual try-on was proposed. So as you can see, style-based virtual try-on is working perfectly, even with the complex misalignment, pose, and different shape, and it giving us a perfect result for our target image. So moving to the first next slide, what it tries to solve. So existing virtual try-on module are limited to accurate garment warping due to the lack of global context, because it basically relies on the local appearance flow. So it creates a limitation for different body poses and misalignment warping. Style-based virtual try-on introduced a novel global appearance flow using StyleGAN. So it covers global flow estimation, and besides, they also introduced a refinement module to guide the StyleGAN flow generator to pay more attention of the local garment deformation. So it also gives a cursor-free model, which basically means the mask of different body shape. So moving to the next slide, if we want to understand the style-based appearance flow, we need to understand first how StyleGAN is working. So as you can see, StyleGAN goal is to give high resolution image, increase diversity of output, more control over image feature. So as you can see, a StyleGAN generator is taking a input and giving output of a person with the same person with different view and angle image. So StyleGAN can work with more different interesting work like this. Moving to the next slide, how StyleGAN generator work. So when it comes to traditional architecture, it takes the noise vector and pass to the generator and give the output. But in StyleGAN generator, it takes the noise vector and it uses a mapping network. Then it also uses an intermediate noise, then pass to the StyleGAN generator. Also, it uses a random noise and give a output. And then generator pass this output to the discriminator for evaluating using the progressive growing. Progressive growing basically aims to provide generator high resolution image by using lower resolution image. Moving to the next slide, how this refinement architecture how this style-based appearance flow architecture works. So as you can see here, this is the baseline for StyleGAN. So StyleGAN, as we know, it takes the two input and use the global style vector and appearance flow. And additionally, this paper proposed a refinement flow network in here to cover up the part of the local feature and local corresponding, and it giving the desired output. So how this whole architecture works? For parser free model, it uses the pre-trained model of FB, then it helps the train helps the F for F and FB has extractor. In F, extractor is Yi-Zhe PB and EPPB, and in F, in FPB, extractor is EB and EG, and it also has a warping module in FPB, WPB, and F as W. And it also has a generator in FPB as generator and F as generator G. So this warping module FPB use a different layer, and warping module WIN for number of layer consists of predicted course flow, FCI as you can see, and FRI refinement flow network. So here is the final equation for FCI and FRI. FCI is using the convolutional method, and where S is sample of operator and U is an unsampling operator, and GN is a garment image, and PN is a person image in the FRI. Moving to the next slide, here is the detailed intermediate result of this work. So here, as it taking into a person garment, and then it giving a final flow, then using the warping network method and giving the target output. As style-based appearance flow for virtual type 1 gives a better prediction for misalignment and different body shape, and it has a high accuracy when it comes to existing model. So moving to the next slide, as demo, as you have seen, there is a result of misalignment case. Even with a complex misalignment case, it giving a perfect image of a person, and it giving a accurate result, as you can see in here. The demo, it taking a different input image and how it giving the output, it showing in here. So moving to the next slide, what we have learned from this paper. So in conclusion, this paper solve a complex misalignment warping case in virtual try-on, and it has an easy architecture to implement, and it has also a disadvantage of, as it is using the StyleGAN, so it slows the procedure, and it also requires a bigger GPU. So it has this limitation for and disadvantage for this process. So thank you. Here is the GitHub link and paper link. Thank you guys.